Now, over a long period, the scores obtained in a particular intelligence test were normally distributed, with the mean score of 70 and a standard deviation of 6. When a test was taken by a random sample of 64 students, so you're not talking about one student, you're talking about many students, okay? The mean score was 68. Is there sufficient evidence at the 5% level of significance that these students differ from the normal students? Okay? Now, the fact that you're not asked to construct your own interval, are you? Does it ask you to construct an interval? You could construct an interval and then you say, oh look, their average is 70 is outside the range, that means they're definitely different. But there's another way of doing this, okay? We can just use a z-score, no bother, okay? So here's what we're going to do. Okay, and this is question 2, okay? So, what's the null hypothesis? So what's H0? H0 is a statement that nothing has changed. What do we say? The students do not differ from the population. Does that make sense? Yeah, the students do not differ from the normal. Do not differ from... We've already done hypothesis testing before, haven't we? Okay. And now part H1, which is the alternate hypothesis. What would that be? Students do differ from the normal. Okay. Now, part 2 of this. What is the 5% level of... So what is the 5% level of significance? That's probably the key word you don't quite understand yet. 5% level of significance. What that essentially means is that you're not within the middle 95%. Okay? So there's your middle 95%, and that always occurs between a set score of 1.96 and plus 1.96. Is that alright? And what we're saying is that if you're in the 5% level of significance, you're either in this range here or this range here. That cool with you? So I'm going to name a set score and you tell me. So what we want is we want the set scores to be in between. We want minus 1.96 to be less than Z to be less than 1.96. Any set scores outside that range are at the 5% level of significance. They're outside the range you want. They're too far outside the normal to be considered the same. Does that make sense? Okay. So, part 3. What is the average? What do we get as our average? Oh, sorry. The population average is 70. But our average was 68. Okay? So, z-score. Are we using this z-score here that we used a couple of exercises ago? Why not? It's a mean to begin with, and a mean means you interviewed several people, and that's why you include the root n. Everybody getting the difference between the two? Okay, nextly, Z equals, what's our mean? 68. Their mean, or population mean 70. Population standard deviation? 6. And how many people did we interview? 64. Okay. This results in a set score of minus 2.67. What do we think about that set score? Are we accepting H0 or H1? Is it in between this? No. So you got to be quite... so, since Z equals 2.67 is smaller than minus 1.96, or you can say is outside the region. Okay, since that happens, so we're basically saying is the test statistic. What do I mean by the test statistic? The Z value. The test statistic is in the critical region. What do I mean by critical region? Anybody? The 2.5% at the start or the 2.5% at the end. Does that make sense? It's in one of those regions. Okay? So since it's in the critical region, and hence we reject the null hypothesis. Alright. Hence we reject the null hypothesis, and we reject the null hypothesis that the students do not differ from normal. We accept, it's so wordy, H1, the alternative hypothesis. And what does the alternative hypothesis say? That the students do differ from the normal. So you write that at the end as well. The students do differ from the normal. Now, I love to tell you that if there's any difference in the first 7 questions, there's not. Do question 5 on your own now. You'll figure it out. It won't be any hassle. So I'd like you to do. You're doing 4, 7, 10, 12 from exercise 10.4. And in exercise 10.5, you're going to do questions 2, 4, and 5. Okay? Did I already do 2 or did I do 3? I did 3.